Hello and welcome to Journeys to the Ice, the podcast of the Antarctic Research Centre. My name's Matthew Wood, and in this series of podcasts I'll be talking to friends and colleagues of mine, many of whom travel south each summer to conduct scientific fieldwork in Antarctica. While focusing on Antarctic science, it is my hope that these podcasts will be accessible to a general audience of scientists and non-scientists alike. After all, the findings of current Antarctic science have major implications for global climate change and are therefore relevant to each and every one of us. For this introductory episode, I talked with Professor Tim Naish, Director of the Antarctic Research Centre and recent recipient of a Royal Society New Zealand Science and Technology Medal, awarded in recognition of his significant contribution to Antarctic science. Welcome, Tim. Thanks for joining us on this first episode of Journeys to the Ice. As an introduction, I was wondering if you could tell us a bit about the history of the Antarctic Research Centre at Victoria University.
Yeah, thanks, Matt. Well, I guess the Antarctic Research Centre's been around ever since New Zealand's had an active Antarctic research program, and that goes back to 1957, which was the International Geophysical Year when Edmund Hillary's team first built Scott Base. And we had two students from Victoria University who went down disguised as Americans and sort of unofficially joined the New Zealand team, and that was, of course, Peter Webb and Barry McKelvey. So there's been a very proud tradition. Every year, Victoria University and the Antarctic Research Centre have had an expedition to the Antarctic, and Peter Barrett, who is familiar to many in Antarctic circles, has been the director for more than 30 years. I've just recently filled those big shoes. And I guess it's in the last 10 years that we've grown significantly with external funding and some large international science projects. And right now we're up to about 20 staff and about 18 graduate students. So from the humble beginnings of Peter Barrett and Alex Pine, and Alex, of course, is our technical expert when it comes to drilling, from those humble beginnings, we've really grown dramatically in the last 10 years to where we are today.
So what is the ARC's current mission? What sort of work do you do, and what are the goals that you're trying to achieve through your work?
Well, I guess first and foremost, the Antarctic Research Centre is interested in Antarctica's climate history. So the history of the ice sheets, the history of the sea ice around Antarctica and its ice shelves. And we're fundamentally interested in how Antarctica has changed in the past and how those changes have affected global climate and New Zealand's climate. So one of the things we're particularly interested in is times of past warmth, times when we know from geological records that the world was warmer than it is today, or as warm as it may be in the next 100 years with global warming. So we're really interested in drilling back in time or looking back in time to see how the Antarctic ice sheets behaved when our climate was a bit warmer than it is today. And we do that in a variety of ways. We do that by getting up against the Antarctic coastline with drilling ships or drilling platforms and getting geological records, so these geological histories which record an archive of how that ice sheets behave through time. Or we do it with ice drilling, where we are involved with taking ice cores out of the ice sheet itself, and we measure the secrets locked in the ice, which tell us about past climates and greenhouse gases in the atmosphere and that sort of thing. And the third thing I guess we've really developed more recently is the use of computer models to then play around with some of those results and test how, say, a change in West Antarctica might have an effect more regionally in the Southern Hemisphere or as far-reaching as the Northern Hemisphere.
In this day and age, how important do you think it is to communicate the sort of science that you do here at the ARC to the general public?
That's a really good question. It's so important. It's part of everything we do. We place great emphasis on the communication of our discoveries, particularly in the context of climate change and global warming. One of the reasons we do our research in past climate or back through geological time is because we can drill back to times when warming occurred for natural reasons, but it was still warming all the same in the past. And we can see how it behaved. We can see what the climate was like and what the ice sheets did. And that's been a major focus of the Andrel project. So the sort of work we're doing is really relevant in helping all of us, really, our policymakers, the public, plan for the future and help explain some of the changes we might expect as a consequence of global warming.
I suppose it's particularly important to communicate directly with the public these days because there still seems to be such confusion over the matter. in the scientific community at least, there's consensus to the fact that yes, global climate change exists, and yes, it is, at least in part, an effect of human activity. Whereas in the mainstream media, you'd be led to believe that there's much more of a debate than there really is.
Well, the way the media undertake research and present news is to have a balance, to have an alternative point of view. So, even although the case for climate change and human induced climate change is 99.9% accepted by the scientific community, media will very often balance one climate change scientist with one skeptical scientist, and the public go away thinking that there's actually much more of an uncertainty, much more of an equal debate going on about climate change and whether it's real or not. I was talking to a news reporter the other week who gets thoroughly fed up with this because he just sees it as bogus and actually irresponsible because the public are not getting a clear picture. They're getting a filtered version because of the media. And he was saying that there is no way that they would present the Holocaust, for example, as a balanced debate where you'd put up a Holocaust denier to balance a survivor of the concentration camps view of the world. And I know it's a rather extreme example, but it's not that far from the situation with the climate change debate. The science is, in the words of the IPCC, certain aspects of the science around global warming are unequivocal. Yet we still pretend there's a balanced argument. We've got to move on and deal with the problem. Now, where there is room for some debate is around what will be the potential impacts of global warming on our planet. And that's where the scientists admit uncertainty. How much will sea level rise? How fast will sea level rise? Those are questions that there is still considerable uncertainty around. But those are questions we know half the answer to, and that sea level will rise. And we have to start doing something about it now while we continue to fine tune the rate and the magnitude of some of these changes.
So, with a topic like climate change, it's clearly important to keep the public up to date on scientific developments as they occur. But as a scientist, do you think there is a potential dilemma of being asked for results or opinions before you feel that the data has been sufficiently tested or reviewed?
I mean, it's a really important issue, and I want to tackle it on two levels. One is the role of scientists now as advocates. And there are scientists who think the best thing they can do is to be very objective scientists and do their science well, and then let others communicate the results and what they might mean in terms of policy or, in the case of climate change, in terms of planning for climate change. I'm not one of those, and there's a large group of us who realize that we have a responsibility as scientists to also communicate what we are finding in a way that is understandable and clear, but also reflects the uncertainty or certainty around it. Now, the problem with climate change is there's always going to be uncertainty, and some of the science is very mature, and we still have uncertainties around it, and that's the nature of science. So it's really a bit of a risk mitigation exercise. What scientists can see on the weight of evidence is that there are many things that are going to happen as a consequence of global warming. We believe the weight of evidence is strong enough that it's better to do something about it now, to communicate it now, than suffer the consequences of waiting too long and then leaving it too late. So the IPCC, the Intergovernmental Panel on Climate Change, when I talk about scientists, I'm really talking about the Intergovernmental Panel on Climate Change, which is a collection of over 2,000 scientists globally working for their governments, the leading climate scientists in the world. And they are not doing new science, they're compiling existing science that's been rigorously peer-reviewed in international journals and often replicated many times. They're weighing up all that science and they're making an assessment of that, of, for example, how warm is the atmosphere getting, how warm is the ocean getting, how fast is sea level rising, what will sea level rise look like out to 2100, will there be more hurricanes in the Gulf of Mexico? Those sort of things are based on rigorous observations and rigorous projections with uncertainties around them. But I think the short answer is that we have a moral responsibility as climate change scientists to be responsible, to be rigorous with what we do, but to also be open and communicative.
So, you've talked about the importance of climate change research to the ARC, but in this podcast, we're especially interested in Antarctic science. So, what is this line of work, and particularly the ability to carry out Antarctic field work? What has it meant to you personally?
I had the opportunity during my undergraduate years and even my master's years at Waikato University to go to the Antarctic. And I sort of thought, what a long way to go to do research. And then what if you didn't get it all right and you can't get back? It just seemed to me a crazy place to go and do research. Whereas some of my friends were just like, oh, well, I don't care about the research so much. It's just a great experience to go and do that. So it took me a while to warm up to the idea of going to Antarctica. And I got the opportunity when I started at GNS Science in my first job after my PhD. A position came up in a big international drilling project that Peter Barrett was running, and that was the Cape Roberts project. First of all, it's a huge buzz, as anyone who's been down there will tell you. When you first get off that plane and you see that landscape, it's like landing on another planet. It's a different place. I get a sense of huge space and huge sensory deprivation. There's no color, you don't smell anything. In some ways, it's quite a bland place, but once you come to terms with the environment, what I realized being down there in the context of the environment is that not only was the science interesting, the Cape Roberts project core was fantastic, but there are some questions about our climate system that can only be answered by going to the Antarctic. And in actual fact, through my experience over the last 5 or 6 years with the Andril program, I've realized it's a really difficult place to work. It's just expensive, it's remote, it's logistically difficult. To do the research down there takes much more effort than it would to do research elsewhere in the world, certainly in New Zealand. So you have to have a fair bit of commitment that the work's important. The group I work with, we all realise that I guess we're at a bit of a cusp in terms of things that are happening to our planet. And, this is the engine room in terms of climate change, and we know so little about it. So that's what keeps us going, keeps us interested, keeps us putting up with all the red tape and the bureaucracy of working down there.
And what can we expect to come out of the ARC in the near future? What's the direction it's going in?
Wow. Yes. Okay. So this is where the vision for the future comes in, and the director should have an answer to that question. I just say hang on to your chairs. We're just going so fast and we're doing so much at the moment. But I think we are aware of our niche. We are aware of our values and what we enjoy doing. I think it's fair to say the Antarctic Research Centre at Vic is not a completely multidisciplinary unit where we do everything Antarctic, from law to tourism to science. We really do see our niche as contributing to climate change science, and particularly to understanding climate from past climate records. I think some of the areas we're definitely expanding into are around computer modelling of the climate system, of taking a holistic approach where we're able to take our observations of the ice sheets in the ocean and put them into a computer model that simulates all of Earth's climate. So we're now working with our colleagues overseas who run these massive global climate models that simulate the atmosphere and the ocean and the ice sheets and everything, and can do it over long timescales, and they need these big supercomputers to do the work. But we're also doing that work in-house now with some of our glaciologists, and our modelers are working at smaller scale, higher resolution on glaciers both in New Zealand and Antarctica, and then feeding those into the bigger climate model. So I think that's definitely the way of the future. Sort of questions we're interested in: how will the West Antarctic ice sheet and the East Antarctic ice sheet behave when the world has 600 parts per million CO2 in the atmosphere? What about when there's 1,000 parts per million in the atmosphere? Now, we can drill back in time, millions of years, to times when the Earth had an atmosphere like that, but we can also simulate those climates with models as well, and work with our geological data to help validate those models. So I think probably modelling. I mean, we are an Antarctic Research Centre, so we've got to always be sending our students and our staff down to the Antarctic. I mean, there's nothing quite like being there and seeing and feeling the environment. You can't get that from a computer screen.
So it's fair to say that for any budding scientists that might be listening, there's still plenty of work that needs to be done and plenty more questions that need answering.
Oh, yeah. I mean, pardon the pun, but we're only just scratching the tip of the iceberg at the moment. The work is very important. It's very topical. I would encourage students that have a passion or an interest in this area to definitely follow their passions and get involved with groups like us.
Tim Naish, thanks very much for your time today, and we look forward to talking to you again soon.
Thanks, Matt.
For more journeys to the ice, visit sciblogs.co.nz/journeys to the ice.